Number 10. Evaluate integral from 0 to 1 of x exponential x dx. This is integration. So in the past question, we have this question from integration. How do we integrate this? I have integral of x exponential x dx from 0 to 1. This is integration with boundary. This is what we call definite integral. If there were no boundaries, that would have been indefinite integral. But with this boundary now, it is definite integral. All right. Now there's a rule in integration that says that if I'm integrating a product function, let me assume I have sine x cos x dx. I want to integrate this. The rule says that if I differentiate one of the integrands, and it gives me the other one, then the rule is just take the square of that particular integrand, divide it by 2 plus c. This is what I mean. If I differentiate cos x, I'll have minus sine x, but what you say is sine x. But let's differentiate sine x. If we differentiate sine x, what you get will be cos x. So since I differentiate sine x to get cos x, I'll just take the square of sine x. So I'll have sine x raised to the power of 2. Divide it by the new power 2 plus c. That is how to integrate this particular function. Why the plus c? No boundary. Okay. But what I have in this exam question now is that I am to integrate x exponential x. Now let's differentiate x. The derivative of x is 1. It cannot give you exponential x. And also the derivative of exponential x is still exponential x, which is not x. That means that I cannot differentiate any term here or any integrand to get the other one. So since it is product, then that means I'm going to integrate this by parts. That means I need the integration by part formula to get this integral integrated. So what do? I have to recall the integration by part formula, that it is integral of u dv equals to uv minus integral of v du. This is the formula for integration by parts. So now let's pick the integral now. Integral of x exponential x dx from 0 to 1. This is equals to, okay, now x and exponential x. One of it will be u, the other one will be exponential x. So let u be equals to x. U is equals to x. Differentiate this u with respect to x. That means du dx is equals to the derivative of x is 1. I'm done with that. Pick the next one, dv. That means that dv will be equals to exponential x. Okay. Integrate both sides. So if I integrate both sides, differentiation and integration will go. I'll be left with v equals to, what is integral of exponential x? The integral of exponential x is still exponential x. I am done integrating. Then I'll now substitute everything into the formula, that integral of x exponential x is equals to x exponential x here now is equals to u. What is u? U is x, so I'll put x there. What is v? V is exponential x. Look at it, exponential x minus integral of v. What is v? V is exponential x. What is du? You go to your differential here and get your value of du, so you can put it here. So du dx is equals to 1. If I write this over 1, I cross multiply. Du times 1 is du equals to 1 times dx is dx. So now, in the place of du, I will bring in dx. Look at it here, dx. So this is now equals to, I don't have problem with this now. This is equals to x exponential x minus, now you are going to integrate exponential x with respect to x. That's integral of exponential x dx. Now, what is the integral of exponential x? The answer is simply exponential x. And then we are given the boundary to be 0 to 1. So we are done integrating. So this is equals to, I have exponential x, I have exponential x. I can factor out exponential x into, what I'm left here is x, then minus, what I'm left here is 1, because you know I've factored out exponential x. Okay, 0 to 1. Let us substitute the values of the upper limits. Then after that, we substitute the values of the lower limits into this integral. So we are going to have exponential 1 into x is 1 minus 1. Okay, we're done with that. Then minus, that's the rule, minus, this time around, we are going to substitute the lower limits, which will be exponential 0 into 0 minus 1. Okay, 1 minus 1 is 0. 0 times exponential 1 is 0. So everything there is gone. I'm left with minus into exponential 0 is 1. Mathematically, from the laws of indices, anything raised to power 0 is 1. Okay, and then 0 minus 1 is minus 1. So this is minus into 1 times minus 1 is minus 1. And then minus times minus 1 is plus 1. So that means that the answer is plus 1, which is C. Okay, this is number 11. So the question says, find the equation of normal to the curve y minus 4ax plus c equals to 0 at the point 0, 1. So these are the coordinates. All right. Now remember, the question says we should find the equation of normal. Equation of normal. So that is very, very important. Since I'm looking for equation of normal, now the question is, what is the formula for finding the equation of normal to a curve? Please note, if I write y equals to, y minus y1 equals to m into x minus x1, this is equation of tangent. But equation of normal will be y minus y subscript 1 equals to minus 1 over m1. This m1 is the gradient of tangent. So for gradient of normal, it is minus 1 over m1, that is say m2, which is gradient of normal, is equals to minus 1 over m1, which is gradient of tangent. Okay, so what is most important at this point is that anytime you are looking for equation of normal to a curve, the formula is y minus y1 equals to minus 1 over m1 into x minus x1. Some authors will use x subscript 0, y subscript 0, but they are just the same thing. So this is y subscript 1, x subscript 1. All right, so this is the formula we need to get this problem solved. So the first thing is, pick the equation there, curve given y minus 4ax plus c equals to 0. So you want to differentiate this. In order to differentiate this, I'll write this in terms of y. That is to say, y is equals to, I'll move every other thing to the right hand side. So I'll have minus 4ax will move to become plus 4ax. Plus c will move and become minus c. Then from here, I can differentiate. I now have that dy over dx is equals to, now, what is the derivative of 4ax? Don't forget, you're going to differentiate this variable x. So the derivative of x is 1. 1 times 4a is 4a. This is just a constant minus c. The derivative of a constant is 0. So this is dy dx. And dy dx of this curve is equals to 4a. We are done with that. Next, We now substitute, okay? This dy dx is the same thing as m, and we know that m is slope, which is the same thing as dy dx, that's gradient of a curve. All right, so having found that, if you look at the formula, we need to substitute everything into this formula. So don't forget the points are given to be 0, 1, where this is point x and this is point y. That is the coordinate of x and the coordinate of y. So we are going to substitute everything into this equation. So I'll have y minus y1, that is this y now, this is y1. So that is y minus 1 equals to minus 1 over m1, which is dy dx, which is 4a. So I'll drop here 4a. Please watch. Minus 1 over m1 is dy dx, 4a. So put 4a here, look at it, into x minus x1 is this 0. So put it there. The next thing now is to, simplify this to get our final answer. So this is y minus 1 equals to minus, okay, this is minus 1 over 4a into x minus 0 is simply x. So that means that y minus 1 is equals to minus 1 over 4ax, because minus 1 over 4a times x is minus 1 over 4ax. We're done with that. Next thing is just to move this minus 1 to the right hand side to get plus 1. So y will be equals to minus 1 over 4ax, which is this. Minus 1 will cross and become plus 1. So this is the equation of normal to this particular curve. And of course it's true because, okay, for equation of tangents, for tangency, m1 is always equals to m2. And for equation of normal, it's important to note this, that m1, m2 is always equals to minus 1. So if I'm looking for m2, that means that m2 will be minus 1 over m1, which is a gradient of normal. So we're looking for the equation that is normal to this curve. And of course, you can see the curve here was 1 over 4ax. Then the equation of normal, which is this now, tells us that the slope m2 is minus 1 over 4a. When this is m1, so m2 is minus 1 over 4a, which is this, minus 1 over m1. Anyways, that's a long teaching. But what is most important is that this is the equation of normal to this curve in the question. Good, that's option D. All right, so let's look at question number 12. It says, evaluate the integral of negative sine x over root 1 plus cos x dx. That is integration, and that is an indefinite integral. So anytime you finish integrating indefinite integral, you have to introduce plus c or plus k, as the case may be, which is a mathematical constant or arbitrary constant. Okay, so let's pick the integral there. We have integral of minus sine x all over root 1 plus cos x dx. I want to integrate this. So we are going to use integration by substitution, whereby if you look at inside the square root sign, you have 1 plus cos x. So let's say, we'll say let u be equals to 1 plus cos x. So let's differentiate this. Du over dx will be equals to, the derivative of 1 is 0, and the derivative of cos x is minus sine x. Okay, Now, when you look inside here, what to do, since you say u is equals to 1 plus cos x, it means that in the place of 1 plus cos x, you are going to substitute u, you pick u, you put it there. Then this dx here, by the time you put u there, what you now have is u, and you will not be integrating with respect to x again. So you'll be integrating with respect to u, since what you have there will be u. So since I have dy dx here, I'm now going to make this dx the subject of formula here. So I can substitute it in the place of this. All right, so let's cross multiply. Dx times minus sine x is minus sine x dx equals to du times 1 is du. Next, I make the x the subject of formula. So dx is equals to du all over this minus sine x will come here, become minus sine x. So I have made the x the subject of formula. When I go back to my integral, I'm going to have integral of minus sine x all over root. What is 1 plus cos x? Look at it. It is u. So carry u, put here u. Then dx, look at dx now. It is minus du over sine x. So you now have times minus du over sine x. All right? Sine x will cancel sine x. And of course, minus times minus will give us plus. So what will be left will be integral of the numerator now is 1 all over root u. Then du. Don't forget that minus and minus will give us plus. So that is gone. So this is what we are going to be integrating. Now this will be written as integral of 1 over u raised to power. What is root and square root sign in mathematics? Raised to power 1 over 2 du. So I can write this as integral of, from the laws of indices, then 1 over u raised to power 1 over 2 means u raised to power minus 1 over 2. I've explained this in the previous question. So then du. Now don't forget how to integrate. In integrating, you have u raised to power minus 1 over 2. Remember, you add 1 to the power. So this is plus 1 all over the new power now, which is minus 1 over 2 plus 1 plus c. So at that point, you are done integrating. You just to simplify the fractions there. So this is going to be u raised to the power of, if you solve this fraction, minus 1 over 2 plus 1. Remember what you do. You find LCM, this over 1. 2 goes into 2, 1. 1 times minus 1 is minus 1. Plus 1 goes into 2 is 2. 2 times 1 is 2. Now minus 1 plus 2 is 1 all over 2. In other words, when you simplify this fraction, you have 1 over 2. So you come to the top here and put, after simplifying this, you have 1 over 2. Then all over, simplify this, you also have 1 over 2 plus c. Next, you clear this fraction here. So this is u raised to power 1 over 2 times, of course, this division will change to multiplication. Then 2 will go up, 1 will come down. So you have 2 over 1, which is simply 2 plus c. So this is 2 times u raised to power 1 over 2 is 2 u raised to power 1 over 2 plus c. Then, what is the value of u? Don't forget, u is 1 plus cos x. So bring it back here. So you have 2 into, what is u? 1 plus cos x. So you have 1 plus cos x raised to power 1 over 2 plus c. And then this is 2. 1 over 2 means square root. So you change it back to square root of 1 plus cos x plus c. And that gives you the final answer. And that is option B. 2 into 1 plus cos x plus c. That is option B.